Okay, your objective today is the students will learn the process of exponential regression in order to find an equation of the exponential function that fits best for a set of data. So you're going to be given a bunch of numbers that represent some data, and you're going to make an equation using your calculator in this form. So today's lesson will be all on the calculator. That's y equals a times b to the x power. Okay, so exponential regression is the process of finding the equation of an exponential function that fits best for a set of data. The first thing you have to do is make sure your diagnostics is on. So the steps are right here. You hit the second button, go to the catalog, and make sure the diagnostics are on. So that is second 0, which gets you to the catalog, and you scroll down to diagnostics. It is in alphabetical order. And you want them on. So you hit enter twice. Enter, enter. Okay? And then our problem is the data at the right shows the cooling temperatures of freshly brewed cup of coffee after it is poured from the brewing pot into a serving cup. The brewing pot temperature is approximately 180 degrees Fahrenheit. So when you take your coffee and first pour it, it starts at about 180 degrees Fahrenheit. As time goes on, the temperature of the coffee obviously goes down. So we would expect this to be decay.
Fran, when you have a moment, can you call me at 4:04? Thank you.
Our goal today is to calculate an equation to predict the water temperature after any number of t minutes. So your first step is to enter the data into the list. So here's how you do that. You hit Stat, Edit, and you should have an L1 or an L2. If you do not have an L1 or an L2, please raise your hand and let me know. There might already be data in there, but to clear it, you just go up to L1, clear, enter, and then arrow over to L2, clear, enter. And then you have to enter your data in exactly as you see it, or it will be, you'll probably get an error or a little different numbers. So please do it as exactly as you see. Okay? 0, 5, 8, 11, 15, 18. Okay, and then L2. Okay, so you might want to double check your numbers, because if you have a little different numbers, you will get different data. Okay? All right, and then if you want to see the graph of that data, you can hit zoom 9. And then if this graph, oops, I have a y equals in there already. So just looking at my graph, I can see that one of my numbers is way down here. You should not have a number like that. So you just want to go back to Stat, Edit, and check your list. And you can see that I accidentally put 17.5 instead of 179.5, which will cause your data to be skewed. So now if I go to graph, pretty similar to what it looks like. Okay? All right, so the next thing you're going to do is we're actually going to get our equation. You only need to do the press Stat, go over to Calc, down to exponential reg, and then hit enter. You do not have to enter it into the y equals. Okay, so we're just going to do Stat over to Calc, down to exponential reg, which I believe is 0. Enter. You can just enter through all of here, down to calculate, and there we go. Okay, so here's our equation, and I believe it wants us to round it to the nearest, let's do 2 decimals. So you can see your A value, 171 and 46 hundredths, so that's about where it starts. And then your B value is 99 hundredths, so that's less than 1, which means it is decay, slightly decaying. And then to the X power, or you could have, they asked actually for the T power. Okay? If you wanted to graph that equation, you could just put your estimated value into the y equals, and you would see that that hits most of your points. It's probably the best fit for it. And then you need to decide if it's a good fit. So on your calculator, since we put the diagnostics on, you should see your R value, which if we rounded that would be negative 0.98. So our value was negative 0.98. Which means it was strong, because if it's between negative 0.8 to negative 1, it's strong, or if it's between positive 0.8 to positive 1, it is strong. So that means our equation represents the data in a good way. Okay? So I will do number 1, and then you'll be responsible for the rest. So a box containing 1,000 coins is shaken and the coins are emptied onto the table. Only the coins that land heads up are returned to the box, and then the process is repeated. The accompanying table shows the number of trials and the number of coins returned to the box after each trial. So typically the left side or the top is L1 and the bottom or the right side is L2. So each trial, you can see that the number of coins is going down. So I would expect this to be decay because coins returned decreases. So that could be a good self-check. Okay, so in order to get our equation, we have to enter our data. So I'll just put a little reminder that this is the stat edit. And it says to the nearest tenth, which is 1 decimal. So stat edit. So you'll have to clear L2s and L1. So L2, go up to it, clear, enter. L1, clear, enter, and then enter your new data. Okay. And then we're going to go to, so I'll write this step, that's to get the data, and then you have to hit stat, calc, and it's the 0 button to get the exponential regression. So stat, over to calc, 0, enter through. Okay, and we're going to round everything to the nearest tenth. So we're going to have y equals 1,018 and 3/10 times 6/10 to the x power. So your y-intercept, remember that's your A value where you start. I like to write it as an ordered pair. So it's 0, 1,018, and 3/10. And then this is decaying because 6/10 is between 0 and 1. And then you want to go back and look at your R value. So your R value is negative 0.9998. So if we were to round that, it would be rounded to negative 1. So we're strong. So it's a strong correlation because your R value is between negative 0.8 and negative 1. Okay? So now we're going to use this equation to calculate the number of coins that would be returned to the box after the 8th trial. So all we're really going to do is substitute 8 in for x. Notice we're rounding to the nearest whole number because we can't have a half of a coin. So you're going to use your equation with the rounded numbers. And then we're going to just substitute 8 in for x. And go over to your calculator. Okay. oops, 10, 18.3. I always like to just use parentheses to the 8th power. Okay, and you get 17.1, which if you were to round that to the nearest number, whole number, it would go to 17 coins. Okay? So I've gone through 2 examples, so your job is to finish the packet, so 2, 3, and 4. Get this checked by me or Miss Young, and then you'll get your informative points, and then you'll pick up your new assignment, which will be for your formative points, and then you'll have a closure as well.